Now let's look at the measure of angles in a triangle. In the figure, suppose that the measure of angle B equals 116 degrees. Let's go ahead and label that. We have 116 degrees. The measure of angle C is 15 degrees. So over here at angle C, we have 15 degrees. And we want to find the measure of angle A. Well, because these are three angles in a triangle, we know that the measure of angle A plus the measure of angle B plus the measure of angle C has to equal 180 degrees. Let's substitute in our known values. We have the measure of angle A that we're looking for. The measure of angle B is 116 degrees. The measure of angle C is 15 degrees, and that equals 180 degrees. Let's combine measure of angle A plus 131 degrees equals 180 degrees. And then subtracting 131 degrees from both sides of the equation leaves us with the measure of angle A equal to 49 degrees, which is what we wanted to find. Now let's look at another figure where we're going to try to determine angle measures from the relationships between the different angles. In the figure, find the measures of angles 1 through 5. Notice that we can start with angle 1 by seeing that it's supplementary to a right angle. And so we know that the two angles together have to equal 180 degrees. If we already have 90 degrees, angle 1 must also be a 90-degree angle. So the measure of angle 1 equals 90 degrees. Next, we have angle 2, which is inside of a triangle with angle 1 and a 36-degree angle. Because the three angles together must equal 180 degrees, we can find the measure of angle 2 by doing the following calculation. If we take 180 degrees and we subtract from it the sum of the other two angles, that is 90 degrees plus 36 degrees, we'll come up with that measurement. So the measure of angle 2 is going to be 180 degrees minus 126 degrees, which is going to leave us with 54 degrees. So now we know that angle 2 has a measure of 54 degrees. Can we figure out the measure of angle 3? Sure, because of the fact that we have vertical angles. So the measure of angle 3 is also going to be 54 degrees. So we've got now angle 3 of 54 degrees. We have a 58-degree angle and angle 4. All three of these form a triangle, meaning that if we take the measure of angle 4, to find it, we'll take 180 degrees and subtract from it the sum of the other two angles. Angle 3 we just found was 54 degrees. We are given an angle of 58 degrees. And so we're going to add these together, 180 degrees minus 112 degrees, to give us the difference of 68 degrees. And finally, if we know that angle 4 is 68 degrees and we're trying to find the measure of angle 5, we notice that these two angles are adjacent and they form a straight angle. So therefore, the measure of angle 5 can be found by taking 180 degrees minus 68 degrees, which is 112 degrees. Our next problem deals with similar triangles. Explain why the triangles are similar. Then find the missing length x. We have two triangles, and notice that they are both right triangles. So we have one angle in each that would be congruent just because of that. But also we have them intersecting in this manner so that I have vertical angles that are formed. And we know that vertical angles are going to be congruent. So by angle-angle similarity, we know that these two triangles are similar to each other. Now, to determine the missing length, we use the fact that if we have similar triangles, then corresponding parts are going to be proportional. We can look at the fact that between the angle that I have noted and the right angle, I have a value of x on the triangle to the right. Between that angle that's congruent and the right angle, I have a value of 10. So I can see that those would be corresponding parts. X is to 10. So I have x is to 10 as my other two values that are given in the triangle are both between the right angle and the angle that's not marked. And so I go from the triangle on the right to the triangle on the left, And here, from the triangle on the right, the 12, to the triangle on the left, the 8. Now, I can begin by reducing this fraction on the right. So x over 10 is equal to, we can divide both numerator and denominator by 4. That gives us 3 over 2. And next, to solve for x, I can do one of two things. I can just multiply both sides by 10, or if you prefer to think of it, since it's a proportion, as cross-multiplying, we can multiply across to give us 2x equals, multiplying across gives us 30, and now we can solve for x, and our x value is equal to 15. And now adding on our label, this x value is going to be 15 centimeters. Now here's an application using similar triangles. Find the height of a lookout tower using the figure that lines up the top of the tower, here, with the top of a stick, located here, that is 2 yards long. And what we have in the figure is we're trying to find the height of the tower h. We have a stick that we've set up so that it's at the same angle so that it lines up with this point here. So that's 2 yards high, and we can measure this length to the stick from this point as 3.5 yards. We now also know that this end point here is 56 yards away from the end of the tower. Now, the reason we can use similar triangles in the problem is the fact that we're going to have a stick that's going straight up and down, which means it's going to have a right angle here. We're going to have an angle which is going to be part of both triangles. That is, it's part of the large triangle, and it's also part of the small triangle. And therefore, we have angle-angle similarity. Because we have similar triangles, we can set up a ratio of corresponding sides. We can say the 3.5 yards is to the 56 yards in the large triangle, as the 2 yards in the small triangle is to the height of the tower h. And now we're going to use cross multiplication in order to simplify this. When we multiply across, we end up with 3.5 times h equals 2 times 56, which is 112. And now we divide both sides of the equation by 3.5 to end up with a value of 32. And so we can say that the tower is 32 yards in height. Now here's a problem dealing with a right triangle. Find the length of the hypotenuse in a right triangle whose legs have lengths 7 feet and 24 feet. Well, let's just sketch this out real quickly. I'm just going to draw a right triangle. I'm not so worried about making sure that I have the right relationship in making sure I have the same lengths of sides or angles. I'm just trying to get a quick sketch of a right triangle, and I'm going to label some things here. So I'll label my right angle. Now, the hypotenuse in a right triangle is the side that's opposite the right angle. So we're going to have our value for x as labeled. We have legs who have lengths 7 feet and 24 feet. We'll take the shorter one and label it with 7 feet, and the longer one and label it with 24 feet. Now, we have a relationship when we have a right triangle between lengths of sides, and that is the Pythagorean theorem. And you may recall that if I quickly sketch out this and label it with A, B, and C, when we have a right triangle with this relationship, we can say that the length of a leg squared plus the length of another leg squared equals the hypotenuse squared. And commonly, we learn that as a squared plus b squared equals c squared. This holds for all right triangles. So we're going to substitute into this formula. We'll have 7 squared plus 24 squared equals c squared. 7 squared is 49. 24 squared is 576. We'll add those together to give us 625. And now we're looking for a number which, when squared, gives us 625. We can find that value by taking the square root of 625, and 25 is going to be that answer for C, and that is going to be the hypotenuse, which we labeled x in our problem. So we're going to have 25 feet as the hypotenuse. Now here's an application dealing with the Pythagorean theorem. A radio tower is supported by 2 wires that are each 130 yards long and attached to the ground 50 yards from the base of the tower. How tall is the tower? When you're working with a geometry problem, it's always a good idea to try to sketch out a picture of this as you're working the problem. So let's just go ahead and start with the tower. I'm just going to have it going straight up and down. We're going to have two wires that are 130 yards long. So let's just look at one of them. We're going to have it tethered over here, and here's the top of this radio tower. Actually, not the top. Well, yeah, I guess we're having it at the very top of it. And we're going to have a right angle. So we're going to have 50 yards from the base of the tower. That's where the wire is going to be attached. And then we're going to have the wire itself being 130 yards long. And we're trying to find the height of the radio tower, which I'm going to label with an X. So we have a right triangle, and we can use the Pythagorean theorem. Our hypotenuse is 130. So we're going to have x squared plus 50 squared equals 130 squared. And now let's evaluate. X squared plus 50 squared is going to be 2,500 equals 130 squared, which is 16,900. To solve here, we're going to subtract 2,500 from both sides of the equation. X squared is going to equal 14,400. And now we're looking for a number which, when squared, gives us this amount. One thing to notice is that for each of these, what you might have noticed is the 50 squared, 5 squared is 25, and then 10 squared is 100, so we end up with 2,500. 13 squared is 169, 10 squared is 100, so we add the two zeros. See the 144? You might recognize that as the 12 squared, and then this would be 10 squared, so we can determine this either with a calculator, or if you get to be pretty familiar with this, you'll see it's 120. And so the answer here would be that the radio tower is 120 yards tall.